In this video, we are going to be looking at the capacitor. What is a capacitor? A capacitor is an electrical instrument that is used for storing charges. It's an electrical instrument that is used for storing charges. Now, the capacitor has what is called the capacitance. The capacitance is the ability of a capacitor to store charge, to store the charges. So that is what the capacitance is, the ability of the capacitor to store charges. Now the capacitance is measured in Farad. Now there are other smaller units measured in Farads. There are other smaller units like Microfarad or Picofarad. Now, what is the relationship between the the charge Q, and this is the charge, the capacitance? What is the relationship between the charge, the capacitance, and the voltage, which is the potential difference? The relationship is given by Q is equals to CV. So if you want to look for C, which is the charge, it will be what? Q is equals to CV. To look for C, divide both sides by V, and then your C is what? Q over V, and so on and so forth. If the material has a dielectric, now remember that this capacitance we are talking about is the one of vacuum or air. Now if the material has a dielectric, that is to say dielectric is placed in between the capacitance, the dielectric is like an insulator. The relationship between the capacitance of the dielectric and the capacitance of air is capacitance, the capacitance with dielectric, capacitance with dielectric all over the capacitance with air is equal to K. So if they gave you the capacitance with air and they ask you to find out of the dielectric, you use this particular formula. Are we getting it now? Now the energy stored in a capacitance or in a capacitor is given by half QV. Now this can also be broken down to half what? CV square. As time approaches, we'll be able to what? To explain more on this, the energy. So in case you are asked to calculate the energy, you use this. Now if you are given, let's say, two capacitors in parallel, let's say you are given two capacitors in parallel, capacitor 1 and capacitor 2, and you are asked to calculate the equivalent capacitor. So for parallel connection, the equivalent capacitor is just the algebraic sum of the two capacitances, or the equivalent capacitance is the equivalent sum of the two capacitances, which is C1 plus C2. However, if they are connected in series, to get the equivalent, you say 1 over C equivalent is equals to 1 over C1 plus 1 over C2. So let's take more calculation on this. Now also for a parallel plate capacitor, the capacitance C is given as EOA all over D. For a parallel plate capacitor, the capacitance is given as EOA all over D, where EO the permittivity of free space, and it has a value of 8.85 times 10 raised to the power of minus 12 farad per meter. The A is the area given in meter square, and the D is the distance of separation given in meter between the two parallel plates. Now let's take calculation questions to buttress our points, or these formulas that have been written here. Now the first question here says, what is the charge on a 300 picofarad capacitor when it is charged to a voltage of 10 kilovolt? Now of course, we said the relationship between the charge, the voltage, and the capacitance is given as Q is equal to CV. Now your Q is the charge, which is unknown. Your C is the capacitance, is 300 picofarad. Picofarad means 300 times 10 raised to the power of minus 12 farad. Okay, now 300 times 10 raised to the power of minus 12, that will give us the picofarad. Now the capacitance rather. Now the next thing is the voltage. The voltage is 10 kilovolt, which is equal to 10,000 volt. 10 kilovolt, kilo means 10,000, so you change this to 10,000 volt. Now working with this, what will be your answer? Substituting in now, our Q will be equals to C is what? 300 times 10 raised to the power of minus 12 times our V is what? 10,000. And when you simplify this, you are going to have 300 times 10 to the power of minus 12 times 10,000. That will give us 0.0. We have 1, 2, 3, 4, 5. 0.0000. That's 1, 2, 3, 4, 5. 3 coulomb. Which, if you change to microcoulomb, it gives you this 1, 2, 3, 4, 5, 6, which is 3.0 times 10 raised to the power of, how many times did we count? Minus 6 coulomb. And Q is equal to 3.0. Now 10 raised to the power of minus 6 means what? Micro. So in place of 10 raised to the power of minus 6, we can put what? Micro coulomb. And that is the correct answer, or 0.3 micro coulomb supposed to be the correct answer. Let's see if there is anywhere we are making a mistake. 10,000 kV. This 1, 2, 3, 4, 5, 6. So we are actually correct. It's supposed to be 3 micro coulomb. Okay, 3 micro coulomb and not 0.3 micro coulomb. Okay, sorry about that. This one was 1.0 kilovolt. So if it is 1.0 kilovolt, it means one will be 1.0 kilovolt, 1.0 kilovolt, and then this will give us 0.00003, which is 1, 2, 3, or this will be 0.00000 1, 2, 3, 4, 5, 0, 3. Now if we count, this is give us 1, 2, 3, 4, 5, 6, which is 0.3 times 10 raised to the power of minus 6 coulomb. Now we said minus 6 means what? Micro. So this gives us 0.3 micro coulomb. And that makes this the correct answer to that question. Now let's take our next question. 3 capacitors with capacitance 5 microfarad, 10 microfarad, and 15 microfarad are connected in series across a fixed potential difference. If we want to take this, say let's say this is the 5 microfarad, 10 microfarad, 15 microfarad are connected across a fixed potential difference of 25 volts. What is the equivalent capacitance? Now I said that when you are finding equivalent capacitance for series connection is 1 over C1 plus 1 over the second capacitor plus 1 all over the third capacitor in this case. If there are more, you continue, but since there are 3, we end at this. So this becomes 1 over C equivalent is 1 all over C1 is 5 plus 1 all over 10 plus 1 all over what? 15. Now this becomes 1 over C equivalent is equals to the LCM of 5, 10 and 15 is 30. So this gives us 30 divided by 5 is what? Is 6. 6 times 1 is 6. 30 divided by 10 is 3. 3 times 1 is 3. Plus 30 divided by 15 is 2. 2 times 1 is what? 2. And this gives us 1 over C equivalent is equal to 6 plus 3, 9. 9 plus 2, 11. So this becomes 11 over 30. Now to get your equivalent, you cross multiply. This becomes 11 times C equivalent is equal to 1 times 30. So 11 C equivalent is equal to 30. So to get C equivalent, divide both sides by 11. Therefore, your C equivalent will be 30 divided by 11. And that will give us 2.7. So our final answer is 2.7 microfarad. And that is option C, 2.7 microfarad. Now the next one says, what is the area of each plate of a parallel plate air capacitor? Now you must take note of this. There's no dielectric, that is why they said air capacitor that has a capacitance of 10 picofarad. Now the capacitance C was 10.0 picofarad. Now let's first of all state it out. Picofarad. Now C will be equals to 10.0 picofarad means times 10 raised to the power of minus 12 farad. That has a capacitance of that. If the distance of separation between the plate is 2 millimeter, it means our D is 2.0 millimeter, which to convert millimeter to meter, divide by 1000, this gives us 0.002 meter. This is 1, 2, 3, 0.002 meter. Now the next one is we were asked to find the area. You don't know the area. Now the permittivity of free space EO is 8.85 times 10 raised to the power of minus 12 farad per meter. Now let's calculate. What will be our answer? We said that the capacitance of a parallel plate capacitor is given as EOA all over D. Now we are asked to find A. So at this point we can cross multiply to make A subject of the formula. So this becomes CD times 1 times EOA is what? EOA. And then to find A, divide both sides by EO. So this becomes CD all over EO. Now what is your C? The capacitance is 10 times 10 raised to the power of minus 12. The distance of separation is 0.002 divided by our EO is what? The permittivity of free space 8.85 times 10 raised to the power of minus 12. And then when you solve this, you are going to have, let's quickly press our calculator, 10 times 10 now that will give us 0.00226 meter square. If you must convert this to points, I believe that will give us this becomes 1, 2 and then 3, which is equal to 2.26 times 10 raised to the power of minus 3 meter square. I believe one of the options here is supposed to be the correct answer. But since then, let's take here to be minus 3 and then take this one to be our answer. So definitely that's how to follow through a problem like this. Okay, let's search for more errors. There's no error. 1, 2, 3, no error. So let's continue with the next question. The next question says, what is the total energy stored in two capacitors, 3 microfarad and 6 microfarad? connected in series in a circuit. Now, if they are connected in series, first of all, we said the total energy E is what? Half QV, which is also equals to half CV square. Now, how did we go from here to here? We said that Q is equals to what? CV, right? Or how did we go from here to here? We said Q is what? CV. Then we can say that half CV square can also be written as half CV times V, because V times V will give us what? V square. Now, if we say Q is CV, so wherever we see CV, we can put the value of what? Q, right? And this gives us half QV. That was how we got from here to this, or from here to this position. So whichever of the formulas you use, you'll be correct. Now, if they are connected in series, it means 1 over CEQ will be equals to 1 over 3 plus what? 1 over C, to find the equivalent capacitance. Now, what's the LCM of 3 and 6? Of course, is 6. So 1 all over CEQ is equals to 6. 6 divided by 3 is 2, times 1 is 2. Plus 6 divided by 6 is 1, times 1 is 1. And this becomes 1 over CEQ. 2 plus 1 is 3, all over 6. Then 3 CEQ is equals to 6. Divide both sides by 3. Your CEQ is 6 divided by 3 is 2. Okay, so that is our equivalent capacitance. Now, we said to calculate the energy, we can use half, then QV, or half QV, or we can use half CV. But in this case, were we actually given any of Q or C in this calculation? It wasn't given. Are we getting it now? So let's improvise. Let's say a charge was given. Okay, we can actually get the answer because one of the options says V here, right? So in place of our capacitance, what was our equivalent capacitance? Is 2, right? So this becomes half times 2 to get the energy. Half times 2 times what? V. 2 times 2 cancels 2, and then your energy is equals to the voltage. So the correct answer is V. This is a very technical question. Like, it's very, very technical. You have to be imaginative in order to prefer a solution to this. Now, if you didn't see the V before, you say the question is not correct because the voltage was not given and the charge was not given, and there was no way we could have looked for 2 unknowns. Are we getting it now? But the option, one of the options carries V, so it's supposed to be 1V, which is also equal to what? V. Let me take that part again. We said we have half CV, or half supposed to be half CV square. So it's still not correct. It's still not correct. Unless that place will be V square. Okay? It's still not correct. Unless that place will be V square. But then, if here we are to be V square, then it will be half CV square, which is half. The capacitance is what? It's 2. So this becomes 2. And then V square. This cancel this, give you V square. So this would have been correct. Let's look at the next question. 2 capacitors, 3 microfarad and 6 microfarad, are connected in series. What is the equivalent capacitance? I believe we've solved this question here. Now, 3 microfarad and 6 are connected in series. What is the equivalent capacitance? The equivalent capacitance is what? That is what we solved just now. 1 over CEQ is equals to 1 over C1 plus 1 all over C2. That will be 1 all over CEQ, also 1 over 3 plus 1 all over 6. 1 all over CEQ is 6, as the LCM. 6 divided by 6 is 2, times 1 is 2, plus 6 divided by 6, that will give us 1. So 1 all over CEQ is 3 all over 6, cross multiply. 6 times 1 is 6, and then 3 times CEQ give us 3 CEQ. So to get CEQ, which is the equivalent capacitance, divide both sides by 3. Then your CEQ is what? 6 all over 3. And 6 over 3 will give us 2 microfarad. farad. So the equivalent capacitance is 2 microfarad. Okay, equivalent capacitance is 2 microfarad. And even in this question, even capacitance is given in times 10 raised to the power of minus 6, so there was no way that this could have been the answer. But anyway, let's leave this question for now for its incompleteness rather. Now, a parallel plate capacitor has a capacitance of 20 microfarad. Capacitance of 20 microfarad. It means C is 20 microfarad, which we can write as 20 times 10 raised to the power of minus 6 farad. What is the potential difference? Now, the potential difference you are asked to calculate for V across the plate required to store the charge of 7.2 times 10 raised to the power of 4 coulomb on the capacitor. Now, how do we solve this? We say Q is always equals to CV. So if we are looking for V, divide both sides by what? C. And then your V will be Q all over C. And this will give us Q is what? Q is 7.2 times 10 raised to the power of minus 6 farad. And our C is what? Our C capacitance is 20 times 10 raised to the power of 4. Okay, this is not minus 6. This is 4. And this is 20 minus 6. And then when you simplify this, what is it going to give to us? If you simplify this, I believe this will give us 36.00 volts. Let's confirm our answers. Now, this will only give us any of the option there if this is minus 4 coulomb, because I know that 7.2 times 10 to the power of 4 is a very large charge, which is too large for questions like this. So this is minus 4, and then when you simplify, it gives you 36 volts. Okay, so minus 4 is here in the question. So let's go to the next question. Next question says 2 capacitors of capacitances. Now C1 giving us 1.5 microfarad, and then C2 0.25 microfarad are connected in parallel. The system is connected to a voltage of 50 volts. What charge is accumulated on the 1.5? What charge? It means you have asked to find Q. Now note that the voltage across capacitance in parallel are the same. Are what? The same. The voltage across the capacitance in parallel are the same. Now we may need to draw diagrammatically or represent this diagrammatically. These are the 2 capacitance. Now they are connected to what? Sorry for my drawing. This is, let's say, 1.5 microfarad. This is 0.25 microfarad. And this is your 50 volts battery, positive and then negative. Now, if this is the diagram, they are connected in what? In parallel. The voltage across capacitance in parallel are what? The same. So this voltage, 50 volt, is across the 0.25 microfarad, and at the same time is across the 1.5 watt microfarad. And of course, we know that the charge is equals to CV. So our charge will be what? The capacitance for the one in question is in 1.5. Then the voltage we said is the same, which is what? 50. And Q will be equals to 1.5 times 50 will give us 75 microcoulomb. So our correct answer, 75 microcoulomb. Why? Because the capacitance was in microfarad, so automatically the micro still remains here, which is microcoulomb. And that is option D as the correct answer to this question. Now, same question. Now, the question says a 2.0 farad capacitor is desired. What should be the area of the plates if they are to be separated by 4.5 millimeter air gap? Now, the capacitance is 2.0 farad. The area is unknown. The distance of separation 4.5 millimeter, which is divided by 1000 will give us 0.00. This is 4.5 divided by 1000, 0.0045 meters. Now the area is unknown. We know that the permittivity of free space is 8.85 times 10 raised to the power of minus 12 farad per meter. So let's substitute in now. Now the capacitance of a parallel plate capacitor is C is equals to what? EOA all over what? D. So our area now, we said this cross multiply CD is equals to EOA. Divide both sides by EO. Therefore, your CD all over EO is equal to A. So your A will be equals to, what was the charge given? It's 2.0 farad. So become 2.0 times the distance of separation is what? Is 0.0045 meter. Divided by our EO is 8.85 times 10 raised to the power of minus 12. Now, if you solve this, it will give you the area in meter. Now, what is that value? And then the answer to this is 1.02 times 10 raised to the power of 9 meter square. And that is option A. So practically, that is how to go about a question like this. First of all, convert all your values and then find the convert all the values, then write out the formula. C is equals to EOA all over D, knowing what each of the parameters in the formula signify. Now, same question. Now you have the dimensions of the plates of a parallel plate capacitor are 8 cm by 8 cm, and they are separated by distance. Now, what are the dimensions? 8 cm by 8 centimeter. Now, what the distance of separation is 2 millimeter. Now, they ask you calculate the capacitance. Now, if they say calculate the capacitance, it means you calculate C. Now, we know that C for a parallel plate capacitor is EOA all over D. EO is a constant, and that constant is what? 8.85 times 10 raised to the power of minus 12 F per meter. The D, the distance of separation, 2 millimeter, which is what? 0.002 meter. Your A is your area. Now, it was given to you as 8 cm by 8 cm. To calculate for the area, what are you going to do? It's very easy. Convert your centimeter to meter for each of them. So this becomes 8 centimeter to meter will be what? 0.08 meter. So it will be 0.08 meter by 0.0808 meter. Okay. Now, to get area is what? Length times breadth, which is equals to 0.08 times what? 0.08, and your area will be equal to 0.08 times 0.08 will give us what? That will give us 0.0064. 0.0064. So that is your area, 0.0064. Now substituting in, C will be equals to 8.85 times 10 to the power of minus 12 times your area is 0.0064 divided by your D. This distance of separation is 0.002 meter, and then your C would be equal to, what will be your C? When you solve that, it's going to give us 283.2 times 10 raised to the power of minus 13 farad. But we know we can easily convert this to picofarad by what? Coming here one times and then adding 1 to the power. So this becomes C is equal to 28.3 times 10 raised to the power of minus 12 farad. We know that 10 raised to the power of minus 12 farad is the same thing as C, 28.3. In place of 10 raised to the power of minus 12, we can put P, which is picofarad. And that is the answer to that question. Now, the next question says, if glass of dielectric constant 5 fills the space between the plates, if glass of dielectric constant 5. Now, what will be the capacitance in that case if it is glass that filled it instead of the air? Now, I told you the relationship between the capacitance of a dielectric and the capacitance in air. We said it will be the capacitance of the dielectric, in this case, which is glass, all over the capacitance in air is equals to the constant K. Now, K is what? Is 5. That is the dielectric constant. C of the glass is unknown. That is equals to capacitance of the air is 28.3 picofarad. This over 1. Cross multiply. This will give us C of glass is equals to 5 times 28.3 picofarad. And that will give us 141.5 picofarad. So that is how to provide solution to this. If they gave you a dielectric, you say the capacitance of the substance, the dielectric, all over the capacitance of air is equals to K. Capacitance of air is usually the one with this one, because our EO is the permittivity of air, which is permittivity of what? Free space. You understand? So this is usually the capacitance of air, the one that is calculated for. You use this formula to calculate the capacitance in the glass or in any material given to you at all. Now the next one says, a capacitance having a capacitor of 2 microfarad is charged to a potential difference of 100 volt. Find the charge. We said the relationship between the charge, the capacitance, and the voltage is given as Q is equals to CV. Now Q will be equals to, what is your C? Capacitor is 2 microfarad times what is your voltage is 100 volt. So your Q will be equals to 2 times this. This 2 microfarad means 2 raised to the power of minus 6 farad times 100 volt. Your Q will be equals to 2 times 100 is 200 times 10 raised to the power of minus 6 farad. We said minus 6 farad means what? Micro. So your Q is 200 micro coulomb, because it's charged, so the unit will be coulomb. That means the answer to be what? 200 microcoulomb here. The next one is a 1.2 microfarad capacitor is charged to 3.0 kilovolt. Now it means our capacitance C 1.2 microfarad, which is 1.2 times 10 raised to the power of minus 6 farad, is charged to a voltage 3.0 kilovolt. Now kilovolt means 3.0 times 10 raised to the power of 3 volt. Okay, compute the energy. Now what is the energy? Energy will be what? Half CV square. Okay, that is the energy, half CV square, which is half. The capacitance is 1.2 times 10 raised to the power of minus 6 times the voltage is 3.0 times 3.0 times 10 raised to the power of what? 3. Everything square. Now this can go into this. This gives us 0.6. So your E is 0.6 times 10 raised to the power of minus 6 times 9. If this square open through 3 square is what? 9 times 3. 10. 3 times 3, 2 is what? 6. And your E, at this point you can punch it to your calculator and you are going to get a particular answer. What will be that answer? Now 10 raised to the power of minus 6, we cancel out 10 raised to the power of 6. 9 times 0.6 is 5.4 joules. Now if you think that these my calculations here, or the cancel actually makes you or confused you, what you just need to do when you get to this point of half times 1.2 times 10 raised to the power of 6 times 3.0 times 10 raised to the power of 3 square What you just do at this point is punch your calculator directly and you have 5.4 joule. That is the answer to that question. 5.4 volt. Okay, I believe this is the end of this video on capacitors and dielectric. If you have any questions, you can always ask in the comment section below. Thank you for your time.